I'm gonna get extra credit.
Oh.
Wait, no, except for Jason Cho. Except for Jason
He's like,
Cho.
remember last year he's like,
Okay,
hey,
do we have any questions on the homework? Were all the answers correct? Huh?
Oh yeah, I got number 5.
How to do number 5?
Oh yeah.
Yeah.
No,
I need help on that one.
Where's my flag?
I
just only said number 3.
It just said.
Oh yeah, I tried to too.
At t equals 0, a particle is located at the point 1, 2, 3. It travels in a straight line, whoop, to the point. That means the formula is going to be linear then, right? 4, 1, 4. Has speed 2, so the speed is equal to 2 at the point 1, 2, 3. Oh, that means right at the beginning. And a constant acceleration. So that means the acceleration vector is 3, -1, 1.
Is it this? -3 plus or minus 3 over 21 over 10.
No.
Ah.
It's
No.
like comes out nice.
What
Comes
class?
out nice.
Alright, I don't do this in here stuff.
It's the end of lunch.
But lunch is like whenever you eat though, so it's like till the end of the day because we're still gonna eat after school.
Oh my gosh.
Should
We're gonna
be
quiz today.
absent.
Just go quiz right now.
Quiz right now.
There's a quiz.
Yeah.
You're in trouble. You're in trouble. I forgot. What are we even trying to find? Write the equation for the position vector.
Like, I tried to remember math and why is there like 2 values?
I thought it was like not the answer to it.
Okay, if this is your acceleration vector, what is the velocity vector?
3x plus c.
3t plus c. Negative t plus c.
That might be the problem.
T plus c. In fact, we should put c1, c2, and c3. Now, is there a way we can compute these constants?
Yeah.
How?
Isn't
I
there
thought you could like
like a
plug it-
point you can plug?
I was thinking you could do like
Oh!
2 equals 2
Square
square root of all
Can you
of
find
them.
the speed and then like
Yeah.
square it equals to
Say that again?
Like to find the speed and then equal that to 2 at
Yeah, that's what I
1,
thought.
2, 3.
Then there's multiple
I was like
speeds.
confused because I wasn't sure whether you use x or y or
Oh, the speed is 2
Yeah.
when t is 0 right here.
Yeah.
So the speed is the magnitude of velocity, right? So if this is velocity, the square root of this squared plus this squared plus this squared gotta equal 2 then. Right? Because the speed is the magnitude of velocity. So 3t plus c1 plus negative t plus c2 squared plus t plus c3 squared equal 4. Oh, but that's when t is 0, right?
Yeah.
So if you plug in 0 for t, you're just going to get c1 squared plus c2 squared plus c3 squared equal 4. Now how do we figure out these plus c's? Cho, what did we do in this problem? Remember you were asking me about this?
I think that was like the next one.
With the next homework?
I think so.
No, this is, remember you came to see me last week, you asked me about this problem?
For what?
Oh yeah.
You better be paying attention!
I remember.
Hey, it's gonna be pretty easy giving grades in this class then.
What?
Okay, wait, number 2?
We're at number 5, Cho.
Wait, what did I do?
Woo! What are we trying to find anyway in this problem?
The
Forget it.
equation of
The position vector. Constant acceleration. How do we figure out these plus c's?
Oh wait, I put plus 3c and then minus c and plus c because that's like, what do you call it? Like parallel to the acceleration thing. That's all I did. Because like,
What? Instead of c1, c2, c3, you did what?
I put 3C minus C and plus C.
Why is that?
I don't know.
No, I'm just wondering why that is.
I don't know.
Oh, wait.
Is it one?
Wait, something's,
I forgot what it did.
So like-
wait. Because the thing, it's traveling in a straight line to the point then.
Oh, yeah.
It's traveling in a straight line to that point from here to there. So doesn't that mean,
Oh, cause then,
wait, the velocity then gotta be,
That doesn't make sense.
I think I see where you got it from.
Cause TR equals one.
Yeah, you did 4 minus 1 equals 3, 1 minus 2 equals negative 1, 1 minus 3 equals 1.
Oh, yeah, that's what I did.
okay, what did you do?
I don't get how that connects.
No, it's like a particle is located at 1, 2, 3, and then it travels to a straight line in the point 4, 1, 4.
Uh-huh.
And that vector itself is 3, negative 1, and 1.
Okay, so this vector here is 3, negative 1, 1, okay.
And that's how I got 3C minus C and plus C.
Yeah, but why would that be though?
But it has to be like parallel to it.
Oh, because it's in a straight line.
Yeah, that's how I did it.
Oh,
Not the acceleration vector.
okay. Oh, that's clever then. You guys understand?
I don't get why
No,
it
can
would
you
be,
explain it to me?
why it would replace AC and C2, C3.
Because he says if you're traveling in a straight line like this, then this velocity vector gotta be a multiple of this one, that's why, to be parallel,
Oh.
right?
Wait,
That's what you're saying, right?
I don't know.
But isn't that like
Okay, let me
the
think.
new vector
Let me think about it then.
equals the acceleration?
3, negative 1, 1.
Oh, that's what makes sense.
Cause
Oh,
acceleration.
yeah.
Wait, is it equals to acceleration?
Because it would be the acceleration
Yeah.
times t plus c, right?
I don't know.
The velocity vector, that means if it's in a straight line, the velocity vector gotta be pointing in the same direction as this is the acceleration vector then, right? So it's gotta be the velocity vector gotta be a multiple of the acceleration vector.
And then it,
Right,
yeah.
cause it's gotta point in the same direction.
Mhm.
So what you did is correct then.
But then, how do you get the collision vector from?
Huh?
How do you get the collision?
Oh, cause now we can figure out what C is. So
Oh.
this is actually gonna be, this is 3C, this is minus C plus negative C, and then the last one is gonna be plus C, like that. So then what do we got here? 3C squared, wait, 3C quantity squared. So that's 9C squared plus C squared plus C squared equal 4. 11C squared equal 4. C squared equal 4 11s. C equal plus or minus 2 over root 11 then. So how do we know if it's the plus or the minus?
Hmm?
How do we know if it's the plus or the minus?
Plug in a point.
Ooh.
No, like, so here's the velocity vector. The velocity vector is gonna be 3t plus 3 times, okay, what if we did pick the positive one? 6 over root 11, and then it's gonna be negative t minus 2 root 11, and then t plus 2 over root 11. Why wouldn't the negative one work? Why wouldn't the negative one work?
Well, if you took the
Because then, t equals 0, it'll go in negative direction. Because the vector will be.
Because it's gonna go the other way?
Yeah, right? Because you're subtracting from 0.
Maybe. Okay, we'll think about that. Finally, the position vector, what are you calling it? You're calling it R? Let's just use R for position vector. So once we get this, the position vector can be the antiderivative of this, so what is that gonna be? Look, this is ugly, 3/2 t squared plus 6 over root 11 t plus some constant. And then the next one will be negative 1/2 t squared minus 2 over root 11 t plus a constant. And then 1/2 t squared plus 2 over root 11 t plus some constant. And is there a way we can figure out the constant? Yeah, right here. When t equals 0, the position is going to be 1, 2, 3. So if I plug in 0 for t, if I want it to come out to 1, this will be 1.
It's just 1, 2, 3.
And that's going to be 2. And that's going to be 3. That's pretty ugly. Is that the answer on the bottom?
Yeah.
Oh, that's hard. Well, that problem came right out of the book, so.
Here's the book.
That's
Yeah, you know, on the website, there's, I think I sent you guys an email about that.
I don't know.
Oh, gosh. Here, let me show you then. These problems, I just took the good problems out of the book that I used when I took multivariable calculus and got a C minus. Okay, look at the website, right here. You see chapter 15 here, vector calculus? Chapter 15. If you click on that, this is the book that I used when I took this class. And so, so you have something to read too. And then I just took the good problems out of there. That's what I did. So if you need something to read, then you can just read that. But then I tried to put notes on there for you so that you don't really need to read. Okay, so what are we learning on today's homework? Let's see.
Oh wait, could we do
Oh, we gotta still do something? What else?
3?
Number 3.
The one that's
The one, duh?
Yeah.
Okay. I guess it wasn't duh then.
Yeah, it wasn't.
Number 3, show that
Yeah, how do you prove that?
the derivative of f cross f prime is equal to f cross f double prime. Okay, now how do you compute the cross product? Look, did you look at the theorems I put out on the top? That's this. That's the second to the last one over there. So kind of, it's basically like the product rule, right? So if we apply that theorem, what are you gonna get? Apply that theorem to this. What are you gonna get? Look, the second to the last one right there. Leave the first one alone. Crossed with the derivative of the second, which is f double prime, right? Plus derivative of the first one, cross, leave the second one alone. It's like the product rule, that's what it is.
Is there a proof for that?
It might have in the book. Or sometimes the book says the proof is beyond the scope of this course. Sometimes it does say that. Okay, and then, what are we trying to prove? We're trying to prove that it's equal to just this one over here, which means this one gotta be 0. But duh, if you have any vector and you cross it with itself, isn't that 0? That's why it's duh. This is 0.
Cross is sign.
Yeah, because cross product, how do you find the length of the cross product? If you have two vectors that point in the same direction, then what's the angle between them?
0.
0, and how do you complete the magnitude of the cross product? Length of the first times the length of the second times the sine of the angle. The sine of 0 is 0. So that's why this one is 0. That's why you only have that. That's why it was dumb.
Cat.
Okay, do we need to do number 4? Do we need to do number 4? We got it.
Oh, I had a question.
Okay, let's do number 4.
Because if it's maximum limit, is
Yeah.
it 2 values? I
Why
thought
is
that was
it-
supposed to be 4
Yeah,
values.
it doesn't make sense to me, but I thought we had to do it.
No, the answers could be wrong because that's Arnold Chang. I made them write it on the board and then I just copied it down.
didn't
Maximum
seem like for the
interval, so
same
isn't it
question.
supposed to be like,
Okay, here is the cycloid t minus sine t, whoop, 1 minus cosine t, whoop. Find the maximum and minimum values of the speed, the magnitude of velocity, and the magnitude of acceleration. Okay, so let's compute the velocity vector. What did you get? Ha.
1 minus cosine t sine t.
Okay, correct. And then acceleration,
You got it.
acceleration,
Sine-
to.
oh,
You don't even hit the look. Just look at. Never
Sine
mind.
t cosine.
Okay, here's the velocity vector. What is the magnitude of the velocity vector? How do you find the magnitude of a vector? The square root of the x component squared plus the y component squared. Okay, let's simplify this puppy. 1 minus 2 cosine t plus cosine t squared t plus sine squared t. Hey, you somebody.
1.
That's 1. So you get 2 minus 2 cosine t, factor out a root 2, and you get 1 minus cosine t. So what is the biggest this will ever be?
1.
1, right?
Yeah.
Okay.
So therefore the maximum value is going to be root 2.
There wasn't an answer.
Huh? What was the answer?
Just 1 and 2.
1.
Oh wait.
The answer was 1?
For
There's
the
2
other one.
common and 1.
Wait, how do I do this?
Wait, what are we trying to find? Are we finding 2?
Wait, no, time out. The maximum value of this is not 1.
It's not. Oh, it's 2.
It's, yeah.
Oops.
Oh, come
Oh,
on.
it's because root 2.
The maximum value of that is not 1.
Oh, yeah.
It's 2. So root 2 times root 2 is 2. You guys see why?
Yeah.
Because what happens when
Negative one,
cosine is
yeah.
negative 1? 1 minus negative 1 is 2.
Itami.
Okay.
Your hair!
Here is the acceleration vector. The magnitude of acceleration is the square root of the x component squared plus the y component squared, but that's always equal to 1, so it's always equal to 1.
I had a question. It says
Yeah.
maximum and minimum.
Yeah.
There's only 2 answers.
Oh, the maximum and minimum. Well, this one is always 1 no matter what, so it's 1 and 1. Now, what about the minimum? Well, what's the smallest this can ever be?
0.
0, so 2 and 0.
Oh, so there's not. It needs to be 0 on there then.
Oh, so that should be 2 and 0 and 1 and 1.
Yeah, because
Okay.
0 is 2 and 1.
Well, let's fix that right now. I don't know how to fix that. Because it's handwritten. Too bad, we just leave it for the next class to figure out.
Oh yeah. 'cause-
Anyway, next year, somebody else is teaching this.
Mr. Ye.
Mr. Ye's is gonna have to teach this next year. I'm getting too old for this.
Who's gonna be in that class?
Like
I don't know.
10.
I heard Mr. Rubash said there's like ninth graders in algebra.
Ooh, what was it, Mr. Rubash?
honors. I don't know. Well, somebody's gonna have to do it.
Those from
Miss Yo.
Come on, I've been doing it 30
Well,
years.
someone who teaches
Huh?
calculus.
It's time for somebody else to do it. Okay, now tonight's homework is basically, look at it. Write the equation of the tangent vector and the tangent line at the indicated point. Okay, this is what you gotta know. If you have a curve, when you compute, okay, so you know what, you can think of the position, here, let's just do it two-dimensionally first. So let's say a particle is traveling on a curve. You can kind of think of the position vector as a vector that goes from the origin to that point. That's how you think of a position vector. Now what about the velocity vector? The velocity vector is always going to be tangent to the curve. Doesn't that make sense? Because it's the derivative? And remember when we did the uniform circular motion problem? You guys remember this, right? Remember how the velocity vector was tangent to the circle? So it's the same kind of thing. So the velocity vector is always going to be tangent to the curve, and then therefore we can use that vector to write the equation of the tangent line. So let's look. Here, what the heck? Why don't I do one of the problems for you? No, I'm going to do a similar problem. I'm not going to do the same problem. Okay, so suppose we have a position vector that is cosine t, sine t, and t. When t is equal to 3 pi over 4, find the tangent vector, and then write the equation of the tangent line, because that's what you're gonna have to do in problem number 1. Okay? So, what you do is you find the velocity vector, because the velocity vector will be the tangent vector. So what is the velocity vector?
Negative sign.
Negative sine t cosine t 1. So when t is 3 pi over 4, so at t equal 3 pi over 4, what is the velocity vector at that point? At that time, rather. Plug in 3 pi over 4 and you get?
Negative.
Negative root 2 over 2.
Negative.
Negative root 2 over 2, 1. So that is the tangent vector at that particular point in time. And then how do you write the equation line of the tangent line? What do you need to write an equation of a line? A point and a vector that points in the direction. So we got the vector, we just need the point. Well, what are the coordinates of the point at t equal 3 pi over 4? You go to the position vector and you get? Plug in 3 pi over 4. Negative root 2 over 2, root 2 over 2, 3 pi over 4. So, parametrically, how do you write the equation of this line? X equals, remember? Or have we forgotten? Negative root 2 over 2
Calc.
minus root 2 over 2
Oh,
t. Y equals root 2 over 2
Plus.
minus
Minus.
root 2 over 2t.
Or
Z equals 3 pi over 4
plus t.
plus t. There you go. That's the equation of the tangent line. Right? Remember, when you have the coordinates of the point, you just put it here, here, and here. And then if these are the components of the vector, those are the coefficients of t. That's how you write the parametric representation of the line. So, this is pretty easy. I don't think I have to tell you anything else. Yep. That's all you need to know for this homework. So the velocity vector is tangent to the curve. Okay? And then you can use that vector to write the equation of the tangent line. And then I think tonight you're going to compute some angles. I think what you might, I don't know what, like on the test, what kind of question could I ask? Like, here's the velocity vector. Oh, I just thought of a problem. Find the angle that the velocity vector makes with the acceleration vector at a certain time or something. In fact, why don't we just do that for funsies? At t equal 3 pi over 4, right here. Let's say that this is 3 pi over 4. What is the angle that the velocity vector makes with the acceleration vector? So, here's the velocity vector. How do I get acceleration vector?
0, 0, 0.
No, you gotta take the derivative.
No, but you're putting at the negative 2.
Yeah, you were.
What's the derivative of this? Negative cosine t, negative sine t, 0. So at t equal 3 pi over 4, what is the acceleration vector then?
Um,
0, 0, 0.
Root 2 over 2,
negative.
negative root 2 over 2,
0.
0. So, how do you find that, at that particular point in time, how do you find the angle between the velocity and the acceleration angle? You use the dot product thingy, right?
Oh, God.
So the cosine of the angle is equal to the dot product. Okay, what's the dot product? This times this.
Oh.
This
Negative.
times negative
1.
half.
Oh,
What?
Negative 1.
Plus this times this. Plus this times this. It's 0 over the length of this vector.
Wait, you already know what's pi.
This is okay, we're just going to do it for funsies. The length of this vector will be this squared plus that squared. Half plus half plus 1. And then what's the length of this vector? The square root of this squared plus this squared plus this squared. Half plus 0. But then it comes out to 0, therefore the angle got to be 90 degrees because the dot product is 0. Oh, I wonder if, is that something from physics? My physics is not too good, that's why. Like, it doesn't matter how the particle is traveling, at any point in time, the velocity vector is going to be perpendicular to the acceleration vector.
Isn't that
I
true?
think we should.
Because in uniform circular motion it is, right?
Yeah.
Because it's always toward the middle centripetally, right?
But that's not always.
Yeah, it's not always true, because like if you're accelerating.
Because this is not a circle. However, what if at that point you kind of think of it as a circle though? It's kind of circular right there. In fact, aren't we learning this at the end of this chapter, Joe? Curvature?
In this chapter? Or
Yeah, at the end of this chapter. The curvature of a curve is like how it curves.
I mean, I guess it,
So, that's interesting. I don't know.
You should ask them this.
So even though,
Ask Mr. Hyman.
Yeah.
yeah,
Ask Miss Lee.
what did you ask?
I don't.
We don't understand.
Okay, well, anyway, we computed it. Anyway, the angle is 90 degrees. I wonder if that's always going to be true. General case.
I think it would in any circle or any curved
Hmm.
path.
Then I wouldn't give that problem because it's always going to be 90 degrees.
Okay.
There's one of the answers 90 degrees and one of them worked out. Is it the same one?
All right, okay, we are done. I don't know what time this class ends. Assembly, no, this is not. No.
In 11 minutes.
Really? Okay.
Let's play games.
Let's take that.
Play games. Tomorrow we'll play games.
Is it the